In this video, I'd like to go over the notes and the homework for 4.8, use isosceles and equilateral triangles. So this is the cover page of the whole document. So we're going to go to page 9. So let me just get us to page 9. Okay, there we are. There we have it. Okay, so this is where we're going to start taking our notes. Now you should have these notes already, but I wanted to go over and make sure that everyone has exactly the same thing. Okay, so first off, this is a picture right here of an isosceles triangle, and it's all nicely labeled for you. You've got your vertex angle at the top. The base angles refer to this angle right here and this angle right here. This is the base, and these are the legs. Notice the legs have these markings, which tell us that they are equal. And what we're going to learn in this section is that if a leg is equal, the angle opposite the leg is also equal. So that means this angle here opposite this leg and this angle here opposite this leg are both the same measurement. So if you know one, you know the other. Okay, so let's look at these notes. So legs are defined as the two congruent sides of an isosceles triangle, here and here. A vertex angle is the angle formed by the two legs, so it's formed up here. The third side of the isosceles triangle, which is here, is called the base. Base angles are the two angles adjacent to the base. Okay, base angles are adjacent to the base and they're across from the congruent legs. Okay, let's see what else this page has to offer us. So we have the theorem, which explains exactly what I just went through, and we have the converse of the base angles theorem. So these theorems are exactly what I just talked about. So let's read this. So the base angle theorem, if two sides of a triangle are congruent, then the angles, you can either say across or opposite from them, are congruent. And the converse of the base angle theorem says that if two angles of a triangle are congruent, then the sides opposite them are congruent. Okay, so basically the same thing I just went over. So let's slide down a little bit more. And here's some corollaries. If a triangle is equilateral, then it is equiangular. The corollary to that is if a triangle is equiangular, then it's also equilateral. So let's think about that. I can't really draw anything here, I don't believe. I mean, maybe I should give this a try. Let's see, can I draw a triangle? Oh, I can. It's not a great triangle, but I can draw it. So if we know that this angle, this side equals this side, and it equals this side, then it's equilateral. The second I say it's equilateral, I then know that this angle equals this angle, which equals this angle. So add this drawing to your notes. Okay, we can go a step further. If I have three angles, let's put an X in each of those angles. So this is going to be an X here inside the angle. We'll put an X here inside the angle. I can't really go inside, but you know what I mean. And an X here. That's the measurement of each of these angles inside here. Okay? So I have three X's. So 3X is what I get if I add all three angles up. And we know from our 180-degree rule that every triangle has 180 degrees. So there's 180. So if you divide 3 into 180, you're going to get 60. So that means that every single equilateral triangle is equiangular, and every single one of the angles inside that kind of triangle is going to be 60 degrees. Okay, so that's huge. So definitely add that to your notes. Okay, let's move on to the next page, which is page 11. Let me just get into that. So hang on while I get that going. All right, so let's go on to the next page because we're done with our notes. Let me just make sure and verify that. Yes, we're done with our notes, so let's go through the examples. So look at this triangle, and I went ahead and labeled everything, so please do the same thing. A triangle DEF, so inside this triangle, we can see it's DEF. They're telling us that line segment DE, which is right here, is equal to line segment DF. So I labeled them legs. Then to practice the parts, I labeled this the vertex, these the base angles, and this the base. So go ahead and do the same thing. So what I know is congruent angles are going to be the base angles, right? So that's angle E and angle F. They are the base angles of an isosceles triangle. So those are the two congruent angles that I would therefore name. Okay, next example. Find measures in a triangle. So find the measures of the triangle. So what I did was I noticed that you have these 3 red lines. Those 3 red lines told me that I had also 3 equal angles. I labeled those angles X. So I have 3 X's, and they're going to sum up to 180, just like I did before in the example, and therefore every X is going to be 60 degrees. So an equilateral triangle is always equiangular. An equiangular triangle is always equilateral, and when the 3 angles are all equal, they are all going to be 60 degrees. So that's a very important takeaway. Okay, use isosceles and equilateral triangles. So it says solve for the values of x and y. So what I did was I started working inside this triangle first, and I noticed I had 3 equal sides. So I put hash marks, 3 equal hash marks to indicate 3 equal sides. Then I said, oh, thank you very much. This is 7. They gave us that. Therefore, this has to be 7 in the red, and this has to be 7. So I already know now that x is 7. Okay, go on to the next triangle. This angle equals this angle. So therefore, the sides opposite them, the green side here, the green side here, are both going to be the same. Well, I already know that this side was 7 because when I was working in the other triangle, I defined it as 7. It's still 7. So if this is 7, then this has to be 7. So therefore, y plus 4 equals 7, and then solve for y, and you should be getting y equals 3. Okay, let's go on to example 4. Okay, so example 4 is a good one because they give us the vertex angle, and they have us find the base angles. So when they gave us the 50-degree vertex angle, I know there's 180 degrees inside. So that means I have 130 degrees in my base angles. Well, I have 2 base angles. So therefore, I have to divide the 130 degrees by 2. And when I do that, I get 65 degrees in each one. Okay, so those are 3 or 4 really good examples. I said you can skip this one. I didn't particularly like that drawing. And then in terms of skill practice, this was the homework. So let's go over this as well. So this says, okay, vocab, define the vertex of an isosceles triangle. So I said it's the third angle of an isosceles triangle, not equal to the base angle. Okay, so let me just write that in. So it's the third, and this should be angle. So make that little angle symbol. Okay, so write that down. This is going to disappear in just a second. Okay, so you can also say that the vertex angle is opposite from the base. So here's the base, it's opposite the base. And you can also say that the legs are adjacent to it. Here's the leg, here's another leg. So all 3 green dots help me define the vertex angle. So be comfortable with all of them. All right, next thing. What is the relationship between the base angles of an isosceles triangle? And I said base angles are congruent. That's the relationship. Okay, they're congruent. And so that's always going to hold. Okay, so let's go further down this page. Okay, so what I did was this. I did this in 3 series, or 4 series, I guess. Each one of these statements is a standalone statement. So you've got to view the triangle here with only that information. So I'm going to have to talk this out. So if AE, so this is the green one. I wonder if I have a green pen. Let me just look. I might be able to find the green. So yeah. Okay, so here's the first piece of it. They were talking about this AE and ED. Okay, excuse my terrible lines here. If you know these guys are equal, okay, so if these guys are equal, then what you know is that angle A has to equal angle D because those are base angles. So that's how I got that answer. Okay, so think about that. I'm going to erase this and we'll go to the next part of it. Okay, so then let's do the orange one. So, okay, I've got orange. Okay, so next they say if AB, so AB is here, so if AB equals EB, so look where EB is. If these guys are equal, okay, this is equal to this, then where are the base angles? Well, one of them is right here. We can call that angle A. And another one is right here. Now, this one that's right here, right in here, I can't call that angle E because that would be too confusing. Because angle E could be any of these angles. So I have to call it angle AEB. And that's how I got AEB. Okay, so write that down if that's helpful to you, because I'm going to erase it in just a second, and then we'll do the blue highlighted piece. Okay, let me just find some blue. Okay, so for the blue one, they say if angle D, so here's angle D right here, if that equals angle, okay, CED, again, that's this one right here. It's only that one right there, just the very left, the very far right angle. If those two angles are equal, what does that tell us? Well, it's going to tell me that the opposite sides are equal. So CD equals CE. And look at the notation. Use your line segment notation. All right, so that focuses on the last one. Now we can focus on the last one. So I have gray, which I can't take away, so I can take away this blue. Okay, so for the gray one, it says if angle EBC, okay, EBC, that's this angle right here where my cursor is. If that angle equals angle ECB, which is this guy, then what do I know? Well, I know the side opposite, BE, and the side opposite this one, EC, are congruent. So that's all set for you. Okay, I thought those were good problems. Okay, let me look at these next 3. So let me just slide this down a little bit, because I made this a little bit bigger for us. Okay, so I can't erase these things, so I just have to go with it. Okay, what I started off seeing is that you have 3 equal angles. I immediately call them 60-degree angles because I know that if I have 3 equal angles in a triangle, they're all 60 degrees. Okay, they want me to figure out this question mark out here. Well, if all my angles are equal, all my sides are equal, and since they gave us this blue one right here of being 12, I now know that every single thing is 12. Okay? All right, next one. Look at this one. They gave us 2 60-degree angles. That's 120 degrees. I know if I have 2 60-degree angles, the third one has to be 60 degrees also because I have 180 degrees in a triangle. So I now know the angles are all 60. Given that, I know the sides are all equal. They give me one side of 16, They've given me the other side. So the question mark here is 16. And number 9 says they give us the information that you have these equal sides. If you have equal sides, you have equal angles. And they want to know what the angles are. So you could just remember that they're all going to be 60, or you can just do the math and make this x, make this x, make this x, and say 3x is 180, divide both sides by 3, x is going to be 60. Okay, so we've got another little page here. So we're drawing diagrams. So here it says a base angle in an isosceles triangle measures 37. So draw yourself an isosceles triangle. And I'm going to ask you to label isosceles triangles on the quiz, which is next class. So you have to really know what you're doing here. So when they say base angle, you have to know that those are the angles that are opposite the equal sides. So if they tell you these are each 37, and they want to know the vertex angle, and you have to know the vertex angle is the angle formed by the two legs, and it's opposite the base. You've got to know that stuff too. 37 plus 37 is 74. So far in this triangle, I have 74 degrees. I need 180. So do your math over here. 180 minus 74, remember how to borrow. Bring down the 6, and then now you had borrowed from the 8, so that's a 7. So 7 minus 7 is 0, and then 1 minus 0 is 1. So the remaining angle, that vertex angle, has to be 106 degrees. Okay, so let's slide down. We've got a couple of more things. Okay, it says find the value of x. So they tell us that all the sides are 5. Once they tell us that, you've got to label all your angles as being equal. Then you see they give you one angle is 3x. Now, if you remember that every angle is going to be 60 in an equilateral triangle, then you can just divide that 3x by 3, and you get an x value of 20, and that you're done. But what if we don't remember that? Or what if we want to try another way to solve this? So if this is 3x, then this is 3x, and this is 3x. Add the 3x's together, you get 9x, divide both sides by 9, and you get x equals 20. Done. Okay, so that was a good problem. Going to the next one, we went from equilateral triangles to now isosceles triangles. So what I see is they gave me that these angles are equal. I can then give myself that this angle of this side has to equal this side because opposite sides are going to be equal. The legs are equal. So set these two equal and solve for x. It's a two-step problem. So first thing you're going to do is take the 5 away from both sides. You then get 5x equals 30. Divide both sides by 5, and you get x equals 6. And we are done. Okay, last one on this row. It says that we have equal sides. The second it says that, make your angles equal. Then they're looking for x. So 9x has to equal 72. Okay, that's just a math fact. 72 divided by 9 will give me 8. And that's done. And then we have one more thinking problem here. So it says, describe and correct the error made in finding BC in the diagram shown. Okay, so they know that A equals C. Okay, yep, I see that. Therefore, AC equals BC. Nope. If A equals C, then AB, which is opposite C, has to equal BC, which is opposite A. So they really should say that AB is congruent or equal to BC, and they are both 5. Okay, so they picked the base angle, or the base side, and set that equal to the legs, and they should not have done that. Okay, so that concludes this. So I hope that helped you check your own notes.